So we know what P and Q. We want to find out what P and Q are. We give a generic value U, an angle alpha for the toss. Okay. And then following that, it's going to be U cos alpha and U sin alpha. Is everybody cool with that? All right, we're going to set up our four equations. So we have Px equals simply U cos alpha. Phy equals U sin alpha. Take away GT. Sx will be UT cos alpha. Sy will be UT sin alpha minus a half GT squared. Did you guys convert to decimal straight away? Yeah. All right, we'll go over decimal straight away then. So instead of G, we'll put in 9.8. Now the reason why you might convert to decimals in this question is you can see the way the answers are in terms of decimals. So it might be handy to have the 9.8 and the 4.9 in straight away. So half G being 4.9. Alrighty. Now, you know the range is 60 meters away. So does that mean you put the range formula equal to 60? Did you do that? First things, yeah? So, just don't want to go down the exact same route we went last time, okay? Nobody wants to see that again. Now, what do we go for this time? T equals 60 over U cos alpha. Is that right? Then, what do we know about the range? Is Sx is 60, but its Sy is? Would everybody agree the Sy is 0 at the same time? Because it hit the ground. So to me that means plug in the T value into the Sy equation. Everybody go with that? Makes legitimate sense. And the Sy equation in turn will be equal to 0. So, what we get here is Sy equals U by 60 over U cos alpha sin alpha minus 4.9 T squared. Oh, lads. What did I not see last week? I'm just going to convert them all to tan alphas. Is that it? How did I not see that last week? Oh, never mind. Alright. So, does everybody see the sin alpha and the cos alpha? Everybody see the sin alpha and cos alpha? What can I put that in, equal to? Tan alpha. So it's going to be 60U tan alpha. Oh, it's the U squared is the issue, no, remember. What's 4.9 times 60 squared? And we got the number for that? 4.9 times 60 squared. $17,640 divided by U squared cos squared alpha equal to 0, okay? Now, what was the problem I found last week? Does anybody remember? How many variables? 2, and the U squared is different than the U as well, which means I can't really mix them together as much as I'd like. So I would stop there, and then I'd evaluate the other parts. The only other trick I can see is you turn the 1 over cos squared alpha into what? 1 plus tan squared alpha. I suppose in a way it minimizes the denominator, so it's probably worth doing, okay? So I'll do that now. Yeah? Did we use concept in what U? Oh, the one on the right cancels, doesn't it? Yeah. Sorry, yeah, my fault. And then we're just left with U squared. There might be a chance of a simultaneous equation, actually. Never thought of that. But Use the simultaneous equation. Alright, let's keep going. I'll change this into 1 plus tan squared alpha. Is that cool with you guys? So 1 over cos squared alpha is the same as 1 plus tan squared alpha. So I'll just rub that out and put in 1 plus tan squared alpha on top. Oh, sorry, the other side. Alright, I'm going to leave that alone now. I'm not going to bother evaluating it any further just for a minute because I just want to see what else I have to work with. I know I need another equation, okay? So then once I get the other equation, I can be informed as to what moves I should make to make both equations work together. There's no point doing work that I might have to undo later on. So what else does it say? Its greatest height above ground is 5.625. So what's the part for the greatest height? Py equals 0. So this equals 0. So you get 9.8t equals u sine alpha, and then it's u sine alpha over 9.8. Is that okay for greatest height? What formula do I put that into now? Since we're talking about greatest height, we're going to put that into SY, aren't we? Just after thinking of something. No, same deal. I was just about to say SX would be 30, wouldn't it? Why is SX 30? Yeah. That's interesting now. I think I just found a really cheap way of doing this. Yeah. Actually, go on, I'll have a look at this right now, alright? Would everybody agree it's symmetrical? What do I mean by symmetrical? Huh? Yeah. So if you're on symmetrical grounds and you go all the way up and all the way back down again, okay? The greatest height will be at half the range. So I actually technically know Sx equals 30 then, don't I? Here's a cheap trick now. I'm just after thinking of it this second, alright? See this formula here? See the Sx formula? Instead have it equal to 30. Does that make sense? Look at this. Sx equals 30, so S equals ut, what's it, ut cos alpha? Is that right? And put that equal to 30. So, would everybody agree that the time it takes for it to be equal to 30 along the Sx is the exact same time it equals 5.625 on the y? Those two times are identical, would you agree with that? So, and we know that Vy equals 0 at this point. Does that make sense? So therefore, what's my other time of flight? I had it at the very top. U sine alpha over 9.8. Okay. I'm going to isolate, that's for the t value. And now I'm going to isolate the t value here, and I'm going to have 30 over, 30 over u cos alpha. Alright. Still going to be faced with two problems there, aren't I? What's the two problems? It's worth having a look at, but what do you think is going to happen here? Huh? Still going to be left with u squared, aren't I? No matter what. So, alright. What's 30 times 9.8 of interest? Huh? 94? 294. Alright. Just a formula you guys need to know. I think I showed yourself yesterday. Make sure your face masks are proper. And the formula is 2 sine alpha cos alpha equals sin 2 alpha. It's in your tables, okay? Works every time. So for example, if I put in 30 degrees, what would happen here? 2 sine 30 degrees by cos 30 degrees will actually equal sine 60 degrees. Okay, it works like that. So, what happens if I multiply both sides with 2? What happened here? 2u squared sin alpha cos alpha equals, anybody? Yeah. And what could I wrap that down to then? U squared? U squared sine 2 alpha equals 588, and then I could have sine 2 alpha equals 588 over U squared. Still two variables though, isn't it? Still two variables, still nothing clear. Well, I'd say it's a good idea, but hasn't linked anywhere yet, has it? There's nothing tangible there so far. So I'm just going to bottle it off in the corner there, and if it comes useful later on, I'll use it. Okay? Now, I think we'll go back to the more traditional approach before I got sidetracked with that crazy idea. I'll just leave it there. Nothing wasted by having it there just in case, okay? It will become useful at any moment. And then you go back down here, I'll get rid of all this nonsense that I just used to get there. Well, it's worth the exploration of it. Now, what did I not follow up with? Have I used the 5.625 yet at all? Haven't used it once. That's because I didn't put input my time. See this time here? I have to input this time here when Vy equals 0. I have to input that into the SY equation and put it equal to 5.625. Is that alright? Still gotta follow the information I was given before I do any fancy tricks, okay? So let's go back down again. So SY, what's that again? U sine alpha over 9.8. So it's going to be U times U sine alpha over 9.8 times sine alpha minus 4.9 times U sin alpha. Oh, we're not going to have the same problem this time. And what's it? 9.8. I remember what I did last week actually that caused all this hassle. There's not going to be a U squared problem here, is there? Remember what I did last week? I halved this value here. Does everybody remember I used 30 over U cos alpha? Does everybody remember that? And when I used that, I caused myself a much more difficult route to the answer. It was correct. What I did was perfect. But the decision not to use 30 over U cos alpha instead of U sine alpha over 9.8 might have caused a much more difficult route to the answer, okay? So let's see if that's the case. I think that's probably the only difference, was it? Yeah. I think that's the only difference. That one little choice will cause a much more difficult route. 5.625. Now, let's work this out, and we get U squared sin squared alpha over 9.8. What's 4.9 divided by 9.8 squared? I think it's like a quarter or something like that. Nowhere near it. 5 over 98. U squared. Be gone. U squared alpha. This looked very promising. Considerably easier than what we were thinking the other day. Now, oh God. Now, did these guys have a common denominator currently? Well, that's over 98. Not over. 98. Okay. I'm going to multiply the 1 on the left by what? What should I multiply the 1 on the left by? This part here. It's going to multiply by 10 top and bottom. What will that effectively do? Yeah, I'll give them both 98s. So, what's 10 take away 5? This is going to be 5 u squared sin squared alpha over 98 will equal 5.625. I'm going to multiply by 98 and then divide by 5. So 5.625 multiplied by 98 divided by 5. 441 over 4. It's very square rootable if you ask me. Very, very, very square rootable. So 441 over 4. This is actually one of the answers we wanted, isn't it? If you go back to the very top, what did we say the triangle was again? U cos alpha and U sin alpha. If I get U sin alpha on its own, it's actually one of the answers I was looking for. It's actually the answer for Q. Okay? So this is good news. Square root both sides, and we get U sin alpha, I think it's 21 over 2, which is 10.5. Everybody happy with that? Now, oh, that's so cheap. Remember my little mystery equation from earlier on? It will work beautifully with it. Because look at this. See the U sine alpha? What can I change this into? I can change that into U sine alpha, U cos alpha, yeah, equals 294. And what can I sub out U sine alpha for? Yeah, that worked out gloriously well. And then 294, yeah. And then U cos alpha on its own would be 294 divided by 10.5. I knew that could have came in handy at any point. 28. So it's 28 across 10.5 up. What'd be a more conventional way of doing that? Did we even use our first equation? Did I even use that? I didn't actually use it. Okay? So, what could we have done differently if I was to do it a more traditional method? Okay? So, we're only at U sine alpha equals 10.5. Is that okay with you guys? Just simply U sine alpha equals 10.5. Okay, we're just going to use that piece of information and we're going to go back up into the first equation and see if there's a different way of doing it. Because let's be honest, we're not going to all think of the same way of doing it. Okay? So let's find out. This is also the problem with correct and implied maths, is that there's so many different routes to the answer. So only 3 people in the country, 4 people in the country actually correct the leaving cert. It's just very, very difficult to correct. Okay? So, what we're going to do next, guys, is, has everybody got the red part taken down? Okay. Now, I'm going to take my U sine alpha equals 10.5. I'm going to bring it up here. I'm going to have a good look at this. Where do you think it would have been most useful? I actually think we went too far there. I'll just actually rub that out. And this equals 0, which is great. So, just going to go back a few steps here. I see U sine alpha right there, do you? So what am I going to put in instead? 10.5. Now, still doesn't solve my U squared cos squared problem, does it? Doesn't solve that at all. However, I can probably get rid of the U. So I can get rid of, if U sine alpha equals 10.5, then U on its own will be 10.5 over than alpha. So here's what I'm going to do. The first thing I'm going to do is I'm going to get rid of no. Come here, you. I'm going to get rid of that part first. And what am I going to put that in as? 10.5. So 60 times 10.5. 630, okay? So we're going to have 630 over, I kept the U for the choice I made. For some reason I kept the U, okay? No big deal. And then, what did we say 4.9 times 60 was earlier? 17,640? I believe you gave me that earlier. Okay? All over U squared cos alpha equals 0. Now, I've decided I'm just going to give these two a common denominator. What would be the common denominator for the two of these? What'd you say? Yeah. U squared cos squared alpha, so I have to multiply the top one by. What do I have to multiply the top one by? U cos alpha. Yeah? Everybody cool with that? Now, what have we effectively done here then? What we've effectively done is I've effectively given them the same denominator, so now the denominator doesn't matter anymore. I'm about to get 630. I'm about to get my answer, thank God. What's the only thing I have to do now? Divide 630 in, and what should be my answer? It's 28, isn't it? Stand down 640 divided by 630, 28. There you go. So that's the more conventional route. Okay? Many weapons at our disposal. You gotta find your own way through it. Okay? Now, part B. A player runs at 5 centimeters per second at the moment the ball is kicked and arrives to catch the ball as it lands. Find the greatest distance that this player could have been from the point R when the ball was kicked. Where's R? Oh, it lands at R. Okay. That's grand. We have our time of flight, don't we? And we know the time of flight. It's here from earlier on. 60 over U cos alpha. And what do we know about U cos alpha? We know that U cos alpha is 28. So what's 60 divided by 28? 15 over 7 or 2.14 seconds. So fractions are better. It takes 15 over 7 seconds from the moment you throw it to when it lands. Does that make sense? Alrighty. Now, alright, that's grand then. That's a very easy question then. All we need to do is, the player is X. He has to be at the landing spot at the same time, doesn't he? He runs at constant velocity 7. So all we need to do is multiply 15 over 7 by 7, and that's how many meters away you can be. So the player starts 15 meters away to make that catch. Is that alright? Okay. That took me